properties, I think. And velocity. Global. Okay, and velocity. And change the color to something that is more visible, like a gray. Okay. And now it's a lot more visible. Can you do that? Yeah, this is optional. You don't have to do it.
Right click, drop it.
If you like it, thank you. Here's the one. Found it out. I'm definitely a beginner in aspect, okay? So. I don't think I have it, but for your project, you can. Huh?
Oh, there it is.
No, you're supposed to collect from literature. Guys, okay, very important. You are supposed to collect diagrams, binary diagrams, etc., from literature, not using Aspen to generate them or HYSYS to generate them. What HYSYS generates depends on the parameters that you have. And you have different choice of parameters. How do you know which parameters are good? You need to get experimental data. Anything that is modeling has 0 value. Don't turn it in. You want experimental data. That's what you're asking. I mean, ideally, if you have the experimental data, you can write your own optimization program to find the parameters. I think we did that at the very end of phase sets. Right? Anyway, how much more time do you have to have a break? We have 5 more minutes. Let me go back to the instructions. Well, you get a few more minutes because I accidentally closed what I should have.
Sorry.
Oh, that reminds me of this picture I just found. I was saving for later. Yeah, thank you.
I can't make that shit up. Like, how do you do this?
I want to know who they paid to design that.
Let's proceed now to the next stage. So you have done, so number 3 was to get a diagram screenshot from Aspen. Now we're returning back to Unison. And the first thing we need to change is the order because the parameters that are being estimated, strangely enough, depend on how you have ordered them. Maybe it has to do with possibly solving nonlinear equations and you have multiple solutions and find different solutions depending on the ordering because the ordering affects the procedure. So I'm going back to Unison. And the first thing I want to go to the bigger.
Can you change the screen?
Thank you. So I went back to Unison. I'll go to the bigger and go to components. Component list 1. So Unison, bigger, component list 1.
This is new?
Just leave it out. Unison,
Yeah,
bigger,
it's a new one?
component
Yeah,
list
we can
1.
actually do it. It's the same file, but we're changing it.
And now say view. This is the order we gave them. is to put ether first, acetic acid second, water next. So what I'm going to do is I'm going to click the diisopropyl ether, sort list, and okay, let's see how this works. I think if I put it insert before, yeah. So select diisopropyl ether, select acetic acid as insert before, and move.
Why does that matter?
Well, as I just said, you get different estimates depending on how you have ordered it. And I hypothesize maybe because of the algorithm used, maybe you're solving system of nonlinear equations where you have multiple solutions, and which solution you get depends on your initial guesses, and your initial guesses depend on how you have ordered it. All right. I don't know the precise output, so I cannot tell you exactly why. So close. So now we're going to go back to, okay, we can X this, and go back to fluid packages. Okay? And click View. The default parameters are still the same. If I reset parameters, you see that we still have the same values we had before. If you look at the Bij, of course it's different order, but if we look at our Excel file, it's exactly the same values. Acetic acid row, ether column 317. Okay, you can see 317 and 317 when acetic acid is row. You can see the 993 water ether 993. It's exactly the same parameters.
Mine are 0.
But you do get different parameters sometimes. Most of the time, the order doesn't matter. But sometimes, and I think in this it does. And we are interested in liquid-liquid extraction. So the natural choice would be to choose parameters that are supposed to be good for liquid-liquid extraction. So we'll choose unified LLE, and we can choose to change all pairs or only one pair. In this case, if I follow the homework, I'm saying choose all pairs. So number 4 says, order the components, use unison to find the parameters of the general RPL activity model, combined with the ideal gas law, selecting unified LLE as the estimation method for all binaries. Report model parameters in Excel spreadsheet. Okay? So I will select all binaries. So click Unified LLE and then all binaries. Parameters change. See the AIJs, no BIJs still, no AIJs, BIJs, and these are the, careful, C's are nothing. What is the C's in Aspen? Alpha 1s. So let's put them, okay, so let's put these readings for the homework
So
assignment.
what is this?
Okay, so we are in number 4 too.
I mean,
We're
C,
doing number 4 now.
Vincent is alpha, I think.
So we order the components,
It's like this.
find the parameters this way, report model parameters in Excel spreadsheet. So we're going to put them on Excel. So that's number 4. Now with the new parameters, check if we get good separation. And compare with Jump. 6, we're going to put them on Aspen Plus and see what Aspen Plus predicts. And finally, we're going to change something. All right. So the next thing is to move those to Excel. So I'll open again the Excel file we had opened. Before we had Unisim default. So here I'll say Unisim LLE. Unisim LLE. The perfectionist again wants to put a space. All right. Yeah, okay. So AIJs, I know they're 0, I don't need to move them. BIJs, I do. Remember, the efficient way of doing it is you click on that empty square upper left corner and press Control Copy and go to Excel and right here Control V. And I have to put the parameters in Excel. For the, these are the BIJs, so let me say something that these are the BIJs. And we have also, let's put the alpha 1 IJs. And for this, I will go here to alpha 1, click alpha 1, click the corner, control copy, go back to Excel, control V, and these are the alpha 1 IJs. And at this point, I would save Excel because you want to print this Excel as your answer to problems 2 and 4, or 3 and 4. 3 and 4. No, 1. 1. All right, so save.
Wait, we changed the order of the
Oh, yes.
the components.
Oh, yes. Oops. Thank you. So let's put a new, let's insert a line. Okay, easily fixed. Control V. Right here. Right click, insert. That's right. Insert. Okay, and the order now is ether first, acidic second, water last. Okay, and this is, okay, I should have, okay, I'll put the BIJ here. So this is ether, acidic, water. All right. Yeah, I'm not going to change them, I'll just simply change the titles. Okay, so that completes number 4. Now, with the new parameters, does the unison become the simulation indicating separation? How do the results compare with the others? So let's go back in unison to, without changing the parameters, return the simulation environment. This warning means what? That for some binary pairs, it will assume ideal mixture. Okay? Okay? There's no reason to have the red light. And you can see here the results. And let's go to composition. And let's specify mass fractions. I know we can specify mass fractions, we will do this thing. But you can see we definitely are getting 2 streams. We go to conditions, you can see the flows. Light liquid 32, heavy liquid 68. So we definitely have phase separation with these parameters. And if I click on the stream, and we specify composition as mass fraction. So this is the ether stream. We get 6% acetic acid in the ether stream. So that's on the high side. And the water stream, taking in the basis to mass fractions. We get about 12% acetic acid, which is exactly what Giacomo reported. So Giacomo had 12% on the water stream, and he had 4% in the ether stream. So a little bit low on the ether stream, right on the nose on the acetic acid, or the water stream. And the water stream was not 2% ether. In our case, it has much less ether. But anyway, they're at least in the ballpark.
Can you go back to the worksheet? I have some different values.
Well, we have to move, guys. I really want to finish this, and now if we finish, I can try to help you at the end. You have the same values here?
Yeah.
If you have the same values here, you're okay. Probably you show something else to show in the worksheet.
No. I have 0.91 H2O.
Okay, so probably translate some parameters correctly.
Okay.
All right. And actually, let's write what we have because I want to compare to what the Aspen diagram shows us we should get. So actually, I will write the values here. So we should have, according to this, ether 0.2%. We should have acidic 11.8.
Oh, I don't know.
And we should have water 88%. So that's the water stream. And the ether stream should have, go back to the ether stream,
Oh.
light liquid, should
No.
have 93% ether, should have 6% acidic, and should have 0.06 water.
Just 0.6%.
Oh, sorry, 0.6% water. Thank you. Okay, so the next problem, number 6, is introduce the unity parameters of problem 4 to Aspen Plus and draw the ternary diagram. Use the tie line that passes through the mixed feed and verify that this matches the Unisim decanter simulation results. Okay? So we're going to go back to Aspen, and we need also Excel to get the parameters from. So open the new parameters in Excel. And we're going to be changing parameters. Where do we change parameters? Under NRTL 150. So let's do work.
Yeah.
So I don't know what you did. I've done something very similar before, and that was my easy solution. Because it wants an entry on all those things that you have. And certainly it's easy to just go with it. Probably there's something to give it before values, but I don't know what it is. All right. So let's change the parameters appropriately. So careful, you transpose. So my first is ether water. Oh, notice by the way that calculation also had AIJs. We put the default, the Aspen LLE parameters, and the Aspen LLE parameters have non-zero AIJs. Okay. But in this case, we have 0 parameters. I'm pretty sure. I mean, we can double check, but I'm pretty sure.
They're 0. They are 0.
That's it, okay. All right, let's go back to Aspen. All right, so let's enter the parameters. So ether water. Ether is first, water second. So I'm going to take water first, water on the row, ether on the column if ether is first. So that's 741 goes on Bij of ether water. So control copy, control V. Automatically everything else becomes here. The other one is the 2055, control copy, control V, and all of the CIJs, which are alpha IJs, are 0.2. I think that's 0.2. The rest is just inaccuracy. So we can just change all of them together to 0.2. I'll change this to 0.2, and I'll change this to 0.2, and I'll change this to 0.2. So I changed all the CIJs. But I still need to change those 4. Next is acidic acid water.